Hi, I'm Mark Esler. Thank you. I work on the Ubuntu security team. I help with their CNA and coordinating vulnerabilities and then auditing software and a bunch of other hats. So this talk is improving FOSS security. And this talk is for anyone who needs to address vulnerabilities in their code base. This is for kind of all levels. There's good advice if you're experienced with this already. But there's a lot of jargon in the security world that we're going to cover first. So the big one everyone's heard is CVEs. CVEs are a communication tool, and their primary purpose is to be the canonical common name for a vulnerability. So the CVE program runs the CVE list. This is the upstream source of all CVE data. And then when a CVE is assigned, other people can use it. So this is Apache using a CVE that is assigned to their software. And then downstream groups will also use that CVE. The real key point is that CVEs are a common name. There's a lot of other purposes for them too, though. But what is vulnerability? Vulnerabilities are different than bugs. Both of them are flaws. But in the case of a vulnerability, the flaw can be exploited to change security context. So bugs, you can't change the security because of the flaw. Common weakness evaluation, or CWE, is a really useful way to categorize and create lineages of vulnerabilities. This is an example of out-of-bounds write. Out-of-bounds write has parent CWEs and child CWEs, but they're useful to describe these to other people so that they understand the nature of a vulnerability quickly. CVSS is how we determine severity of a vulnerability, or one of the ways. They're kind of problematic. They don't always describe vulnerabilities great, but they're the metric we have, and they're better than other metrics. In this case, the attack vector says adjacent. So this vulnerability cannot be attacked over the network, but someone near your computer, like over Bluetooth, might be able to get in. And in this case, we also see that availability is affected highly. That means that this is probably a DOS attack. And then for this, the base score, when you sum these all up with the CVSS calculator, it's a medium or 5.4 severity. So there's a lot of parts to CVEs, a lot of metadata you can include. I'm only going to cover a few things. So this is additional to, the most important purpose, the canonical name. So if you're working on a FOSS project or in a FOSS project and a CVE is assigned to you, you should try to get involved. You should try to help write the metadata, because you can then describe it better than a third party describing how your code works. So the CV description is the most important piece of this. You should explain clearly how the attack works, the impact of the vulnerability, which software versions specifically are affected, and anything else relevant to the vulnerability. And then severity, you can assign the CVSS score. In this case, Canonical assigned this CVSS, but then NVD and other groups might also assign a CVS. References are one of the most useful parts after the description. You should talk about other announcements for the CVE, or bug reports, analysis, that sort of thing. And then if you can, include the CWEs. CVEs have grown dramatically over time. So the CVE program runs what's called the CVE list. It's funded by the US federal government. And so initially, all CVEs were assigned by the CVE board. So there's a board of people who met, and then they agreed on this deserves a CVE. And then in 2005, the MITRE Corporation, who had a big role in the CVE board, was also allowed to assign CVEs. And then the CNA program was created and kind of doubled the CVE count or assignments per year overnight. And that's continuing to grow. So today there's a lot of CNAs. There's distros, programming languages, software vendors. Recently, Daniel Stenberg of curl wrote a really popular blog about bogus CVEs. So I want to kind of just mention not all CVEs are valid. I'm going to kind of run through these quick. In this case, there was a researcher who wanted to make a name for themselves. They spoke to upstream, and what they described was as intended. Git wasn't actually vulnerable, but they wanted to write a blog post, so they got it assigned anyways, and then this causes issues for downstreams that now have to deal with that CVE number. In this case, there's a memory leak, but the memory leak doesn't actually have a security implication. So later on, the assigning CNA revoked the CVE. And CVEs could also be outside of the upstream scope. So for InfluxDB, they don't provide their own authentication. They expect people to use other software to do authentication for the database, like most databases. So a CVE was assigned for it, and then it was disputed. So this is a CVE where the CVE is assigned to an upstream, but the downstream is actually affected. So only the NPM or the node SQLite 3 was affected, not actually SQLite 3. And then the CVE still matters, but they assigned it incorrectly initially. And then there's been kind of a problem where some CNAs are using Git and they're basically grepping for things that might be CVEs, and then they're just blanket assigning it with kind of filler text. So in this case, they assigned a CVE to something that's 8 years old, and if they had translated the Portuguese, they would have found that this is for a homework assignment. But the Git commit has the word SQLite injection in it, so they thought it was valuable. But most CVEs are not bogus. And to reiterate, the primary purpose is to have a name for a CVE. CVE should not describe non-security bugs. They shouldn't be duplicate assignments. You shouldn't assign a CVE to multiple vulnerabilities. Yeah, if it's not a bug or a vulnerability, it shouldn't be assigned. So I have two sections. The first is proactive FOSS security, so what can your project do? So please raise your hand if you work on a FOSS project. Got one person, 2, 3, 4, 5. Okay. And then how many people have written a security policy? That's pretty good. So we have 2 people, which is really good for a room. So a security policy is the most proactive step that your project can take. It lets the reporter know how to contact you. If you don't let the reporter know how to contact you, they might create a bug, a public bug, and then anyone in the world can see it. There's other things you can do in a security policy, like describe your threat model or like what support you have. But the most important thing is to tell someone else how to contact you. The OpenSSF has a few guides, so please go out and write a security policy. GitHub has a new feature. If you enable it, in the top right, there's that green button, and that allows someone to privately report an issue to you. So unlike a normal GitHub issue, this one's private, and you can even say that in your organization, only these members can see it. So you report it, it's private. The reporter gets to fill out however you want to define, you want to receive the report. And then when you're working through the report, the GitHub security team will help coordinate. So if you need a CVE assigned, you can ask GitHub for a CVE assignment. You don't have to go through MITRE. It's a really good feature. And then there's a bunch of ways that you can find vulnerabilities in your code proactively. A big one is static analyzers. There's a lot of different types for different purposes or languages. Bandit's a big one for Python. Coverity is a big one for C. And just use these. Find common anti-patterns in your code that are likely vulnerabilities. They kick up a lot of false positives, but go through them. Others will. There are fuzzers. Fuzzers basically inject different input into your code. There's different ways to write them, but basically you're trying to try patterns that aren't expected by the programmer and see if it can break the code and possibly cause a vulnerability. And then everyone knows bug bounties, but bug bounties is probably the last thing you should do. You want to use other methods to look at your code first, because if you create a bug bounty with money involved, you'll get a lot of reports that you might not be able to triage in time because there's disclosure periods. So do the first two first before attempting a bug bounty. So second HAP is responsive FOSS security. So when a hacker, security researcher, grad student, developer, or someone finds a vulnerability in your code, what can they do? They could keep the 0-day vulnerability as a secret for themselves. They can file a public bug report. They might demand money. They may brag on a mailing list, or they might privately report the vulnerability to your project. Whether you like it or not, the discoverer has the right and ability to disclose the vulnerability however they want. So communication is key when you are receiving a report. Always keep so if you get a report of a vulnerability, always keep these lines of communication open and positive. A credible report means that the reporter wants the security issue solved. It is your opportunity to steer disclosure. There's lots of different ways to make a unknown vulnerability public. There's a few major models. One is full disclosure. This could be that the reporter reported it on a public bug tracker. But when this happens, the attacker, possible attackers can get this information and then possibly exploit code because nobody's developed a patch yet. On the other extreme is non-disclosure or private disclosure. This is when you, the upstream project, receive a report and either decide not to fix it or to fix it and not make an announcement about it. This impacts SBOMs and downstreams. So in the case of the Kitty terminal, there have been remote code execution vulnerabilities in Kitty. There are likely more, but they don't disclose this. They don't see it differently than other bugs. So as a distribution, I never know when I need to patch Kitty for downstream users because they don't announce it. So between the two extremes is coordinated vulnerability disclosure. This is kind of the sane, happy middle ground. In this case, you receive a report. You keep the information private, embargoed for a set amount of time. You will develop the patch and release it, and you might work with others to help release it. So other people who are also affected and want to patch their code on a certain date. So it's really important to be open and positive about bugs. If you don't want to share or if you're embarrassed by a bug, it's something projects should get over. Admit vulnerabilities and own them. So as an example is the late author of Vim, Rob Moulinaire. And in 2021, he started running a bug bounty. In just under a year, over 130 bugs were reported, and nearly half of those received CVEs. So be like Bram, own your bugs, own your vulnerabilities, fix them, and protect others. You might also receive non-vulnerability reports or things that just are not true. In these cases, still stay positive. The first thing you always want to tell a reporter is thank you. This relationship might last after the initial report, and it can impact how you communicate with them in the future. So coordinated vulnerability disclosure is a very large topic. There's a lot of resources for this. This is an example. I don't think it's fully correct. Obviously, it's overly simplified, but some of the lines of communication can change too. But often you'll receive a report. That might not be the person who discovered it initially, but someone reports it. And then your team might have a coordinator, or you might have an outside coordinator. The coordinator's job is really to mediate between different parties. And then usually you'll, if you're working with many people at once, you'll set a coordinated release date, so it'll be a specific date time when everyone's expected to make things public. And until then, the information is embargoed, and you're not supposed to talk about that publicly. The OpenSSF 2 years ago at LSS had a roundtable talk led by Krob. I really recommend this one. Kind of got me into this work. So periodically update others. especially reporters. If a reporter doesn't feel heard, they'll find other ways to secure users, and that might be making a vulnerability public. So periodic updates is the most important key when you're working with a reporter. Be involved in the CVE process. You know your software well. You can describe it well. If you should help write the CVE metadata, especially the description. You don't always need to make an announcement about your vulnerability, but if it's a high impact one, you might want to make an announcement on coordinated release date also. And document vulnerabilities in the changelog. This helps developers and maintainers. So this is an example from Bram. The text is a bit small, but I want to point out how he writes his security patches and why that's useful. In the commit, he describes the vulnerability and he describes the solution. It's also useful if you can add the CVE ID in the commit message for others, but as long as it doesn't break embargo. The patches should be specific. You shouldn't do style changes or add other features. Make security patches as specific as possible. Other groups like distributions might take your patches and then have to apply it to an older release version. So making this simple for them will help users stay safe. And then to go above and beyond, write a reproducer for the vulnerability. Give an example of how this attack could occur and make sure that it can get fixed. Coordinating with downstreams is kind of an issue of trust. If you might have downstreams that work with your code directly, you might want to include them before a coordinated release date. There's also CertCC, who is really good at coordinating with other vendors. And then another big one is the Linux distros list. If you have a high or medium impact vulnerability, you should send it to them. If you do send it to them, though, they will hold you to account for a 14-day embargo period where after 14 days, everything will become public. If you send stuff to Linux distros, please don't include reproducers there. This should say OpenSSF, sorry. They have the 0-day talk preparing for 0-day about CVD. They have concise guides which describe how to write a security policy. I have some notes on my website, markesler.com, and there's a bunch more resources. Are there any questions? All right, well, thank you.